Good evening and good afternoon and good morning, everybody. Hey, Moshiel, good morning in New York. How are you?
Hey, good morning. Everything is cool. Thank you for having me.
My pleasure. And we have an exciting session today. Thank you for taking the time out of your busy schedule to join us. We'll discuss today batteries. We'll discuss today a very important piece of the battery, which is the current collector. And we'll also discuss how Addionics, the company that you founded, actually innovated this little and important piece of the battery and the effect that it has on the performance of the battery. So yeah, without further ado, let's kick it off. Would be great if you can tell us a little bit about yourself before Addionics, so the audience can get to know you.
Perfect. First, thank you very much, Shai, for the invitation and for this opportunity. Really looking forward to have the chat with you and to expand the discussion about Addionics with the entire Orbia crowd and more people, I think, afterwards when you're going to publish that. So, yes, my name is Moshiel. I'm the CEO and the co-founder of the company. I'm married to Tamar and father of four, proud father and proud husband. My background is material science. I started my academic career at Ben Gurion University, where I did material science, mainly focus on, let's say, semiconductors, metals, ceramics. And then I did, again, my master's also from the same university in the field of semiconductors. This is where I saw the potential and where I wanted to extend my career and to build my career on in that field. And I had very, I would say, good opportunity to move to London, to Imperial College London. Actually, it's a cool story because my master supervisor really convinced me to continue for a PhD. But I told him that it's going to be boring to have all the degrees in the same university, and if I will do a PhD, it's going to be abroad. And then I found this amazing opportunity at Imperial College London in the field of batteries. Batteries were very new to me, but I saw that as an opportunity. Back then, actually, batteries weren't very attractive as today. I think today, thanks to Elon Musk and all the entire revolution of electrification, we see batteries more exciting than it was before. And if you remember the times, it was more than a decade ago, that the dream of electric vehicles, especially in Israel, wasn't very solid with the falling of better place. And I remember that day that I told my mom that I'm going to move to London to continue for a PhD and to research batteries. And she told me, like, batteries? What we're going to do with that? Like, what? Batteries are for remote controls. And I said, you're right, but I believe that this is a good opportunity for me. And also, I believe that this industry will attract more and more talent and funding, and it's actually going to power the world, which we see today. So I did my PhD, 3 years, and then I also did like a 1 year of postdoc. I used to live in London. It was very exciting time in London. I still was single back then, so I also enjoyed the benefits of the city. And I did many things beyond just research. I organized many events and really gathered entrepreneurs and the community in London. And I brought like I would say, Israeli high-tech scene to London, organized like few events, and really started to adapt my entrepreneurship skills and to be curious about that. And after 12 years in academic career, I decided how can I combine all my knowledge in research in academia and the entrepreneurship skills and to combine them together. And that's how actually what led to start the company and start Addionics.
Yeah, so maybe before we switch slide to the story of Addionics, um, two questions. Tell us a little bit about you outside of the professional world, like what you like to do, hobbies, things that are beyond just batteries and current collectors and energy storage.
Sure. So yeah, I really enjoy, I would say, the time with friends, and this is what probably this is my biggest hobby. I really like to cook. Also, I'm a fan of a football team in Israel called Hapoel Be'er Sheva. I have a seasonal ticket, so this is very surprising. I grew up in Be'er Sheva, Omer. It's in the south of Israel. And since childhood, I have like a seasonal ticket. Even if I was, even during the time in London, I kept my seat in the stadium. So I think that's like something that maybe will be surprising. Apart from that, I like to cook when I have the time. Right now, with all the travels, super busy, so less time for that. And of course, to spend time with my family, the entire family. I think the good thing to be close to the family is to enjoy a quality time with the family. Maybe a more funny, I would say, a fact about myself. You know what I'm really scared of? Like maybe it will be a bit ridiculous, but pigeons. This is the most, yeah. I really like, I cannot, if you will put like a pigeon in the room, I will go behind the table, behind the desk, and actually hide and will wait until to go. And I feel like crazy stories about that in the past. But yeah, this is, I think, a very piece that you won't find elsewhere.
And this is kind of like when from young age, because of a certain event, or you just develop this anxiety with pigeons?
Yeah, I believe, I have a snapshot when I was a kid, and I had some issue when I was a little kid, and I tried to solve it, even went to many therapists, tried to solve it. I had parties with pigeons and lots of, wishful thinking how to make peace with those animals, but it's less, I would say, severe, and it was in the past, but still, I would say, not very pleasant. So always when people see me with that in this situation, they are making fun of me. So it's at least I feel that I can make people laugh. So this is a positive thing.
Well, thank you for sharing that. And yeah, let's go back to batteries and how the whole story of Addionics started.
Cool. So as I mentioned, I did my PhD in batteries, and the focus was to better understand the relationship between the battery architecture to battery performance. And back then, I went to all the big battery conferences, and I saw the same agenda every time, same agenda, same concept. Nothing changed. And when I asked people like why the agenda is the same as last year, they told me like it's 20 years like that. And I saw the people, and most of the people were very, I would say, old, not lots of talents. And I came from, as I mentioned, from the semiconductor, where it was very busy, lots of young and talent and funding. And what I realized that the focus is on the chemistry of the battery. And there are plenty of companies, research center, universities, huge companies that all their efforts is how to improve batteries through the chemistry, the active material, the energy, which makes sense because this is like the easy thing to do. This is the mainstream research in the battery. But because the world of inactive component was untapped, I realized that this is probably will be the most exciting. It's less explored, less being researched, even in academia. Maybe only 10% of the activities are related to the inactive component. And the most overlooked component between the inactive component is the current collector. Current collector, and we'll talk a bit further in like the next few slides of what is current collector and what the functionality of the current collector. But the vision was to change the architecture when it started to current collector, how to manufacture that at scale. We realized what are the criteria to make good technology in the battery world. And we took all these, I would say, ideas and I started to pitch the idea all over the world. And I think the best advice that I can give to young entrepreneurs is like engage with the market, even just with an idea, and validate the idea. Get insight, get feedback, understand like what are the chances there, what are the opportunities, what are the pains, and how your solution can actually make a difference in this industry. And the battery industry is very conservative, traditional. It's a complex system, so engineers, people don't want to make change after years of stabilization and optimization. So that's the reason that the innovation is quite incremental. You don't see like a huge step change in the performance. And I remember I took a flight, and I met, this is in the picture, Parp Car from LG, former CEO of LG America, was the first, I would say, battery production in the US for electric vehicles, the Chevy Bolt back then. So he was managing the production, and he introduced me to a Korean guy in LG, that he was the scout there of like new technologies at LG. And I took the flight, I met with him. I remember that moment, like prepared for that pitch, and even ironed my lucky shirt. And I really felt that this is going to be the moment that everything will change. I got the opportunity in front of the, I would say, decision maker and gate, I would say, keeper at LG. Once I'm going to pass in, the way to build a relationship and collaboration with LG is there. And I entered to that room, I pitched, and maybe like for 40 minutes, I really believed that I answered all the questions, and I managed to do it very well. And I was so excited, and I had like amazing feeling. And then after 40 minutes, after pitching, the guy told me, you know, it won't work. And I was speechless. I didn't know what to do, overwhelmed. And I had the best feeling when people say roller coaster. I had this roller coaster in one meeting, best feeling. And then he telling me that it won't work. And I said, I cannot like fly back all the way to Israel with this type of a reaction and answer. I need to come back with some answers. And like a little kid that asks his dad, but please explain me why I want an answer. I cannot like accept no answer. So I started to ask those questions and ask why do you think it's not going to work? What's the issue? And at the beginning, I didn't want to share too much, but eventually I didn't give up, and he managed to answer. And he started to tell me all the challenges. And this is challenges that even big companies, Korean companies, their company tried in the past, and it wasn't smooth. It wasn't very easy. And that was, I would say, the starting point when I took all the challenges. I wrote down the challenges, and that actually was our map. I said to myself, if I will go back to my team and I will tell them that if we are going to overcome those milestones, so I actually changed the challenges to milestone. And I said, if we are going to achieve those milestones, companies like LG will work with us because we'll appreciate they had like challenges, and we are going to achieve them, and they will appreciate that. So the way that I message this meeting or this experience to my team, it's not to say that they told me it won't work and it's going to be very difficult, and we tried, it was challenging. The opposite, I said. I took it to the positive, I would say, way. And I mentioned to them, guys, we had amazing meeting with LG. I met the decision maker at LG, and he told me, if we're going to achieve those milestones, they will work with us. So this is
what year was this meeting? 2000 and
18.
18. So like almost 6 years ago, 7 years ago.
Exactly, 7 years ago was one of my first trip. Actually, back then I spent like few months as abroad in different areas and really wanted to gain feedback from the market. I think this feedback was actually helping us to build a roadmap. So I took all their, I would say, negative point and turned them into our milestones in our, I would say, roadmap. And I think that's the way that we managed to get the attention from the industry, because we really better understand after that meeting and after those meetings with the markets, what are the challenges. So when we introduce the product, the solution, we haven't just introduce the opportunity, but also how we can overcome the challenges. So we were very openly and directly that we're aware about the industry challenges and the manufacturing challenges and the business challenges, and we built like a roadmap and a plan how to mitigate those challenges.
And now 7 years after that meeting, where is Addionics on that map? Is it getting closer to the market leadership?
I believe right now, in terms of current collector, we are the leader, definitely. Definitely, we have the most innovative solution for current collector in the world. We are world leading. We are the only company in the world that really can connect current collector properties to battery performance. No one else can do it right now. And in terms of the product itself, also, we have a few order of magnitudes, I would say, advantage over all the competitors, and there is competition. I won't say there is no competition, but the majority, and we'll talk about it later, we're replacing conventional foil, it's commodity, but in the alternative solution, which still not in wide commercial use, we are leading in terms of our numbers of engagements that we have in the market, the position in the market. So definitely this is something that already there, but there is a long journey forward in order to make it happen globally. And that's our life mission.
Okay, so maybe just to get us all on the same page, and as you know, at Orbia, we have quite a few energy storage experts, and we have also many chemists, but we also have people like me that have no experience in the energy storage market. So maybe spend a few minutes just on what is a battery, what are the components, and what is actually a current collector and the role of the current collector in the battery.
Sure. So in this slide, you can see a basic structure of a battery. And this is a layer pouch cell. You can put it in different formats as well, but for this explanation, I'll use this image. In a battery, you have two electrodes, a separator and electrolyte, and the ions travels from one electrode to another electrode, depends on the, I would say, the state, if it's charging or discharge. So it's actually like musical chairs. And in every electrode, you have two components, the active material. The active material is the, I would say, most traditionally the component that was most researched and the ones that contribute to the energy. And the current collector, it's a 2D metal foil. You have copper on the anode side and aluminum on the cathode side, similar to the foil that you have in your kitchen. And believe it or not, every battery in the world using the same architecture of this current collector since the invention of the lithium-ion batteries in the 90s. So this doesn't change. There are tries to make the current collector thinner and thinner. So maybe in the 90s, it was around 20 micron, 18 micron. And now it could be like below 8, even 6 micron. And some areas also, I would say, they are reporting about the vision to go down to 4 micron. So why do we need current collector? For two main functions. One is by the names to collect the electrons. It's like the metal wires that operating the device, and the electrons collected through the metal foil layer. And the second function is to be a substrate. to be a good substrate to the active material and to act, I would say, as a substrate that require good adhesion between the metal to the active material to the chemistry. And the way that you produce those electrodes, either anode or cathode, usually you take the foil and you spread the active materials on top of that, and then you dry it, calender, and you build your electrode. And in that process, the current collector, it's in the form of rolls, jumbo rolls. These rolls are unrolled in the battery manufacturing process, the electrode process, and the active material deposited on top of them. So it's a single side coated, so always coated from two sides. And that's, the sandwich structure of the battery. And what we do, we focus on these components, the current collector. Traditionally, some of them, like even the aluminum, is not included in the breakdown of the conventional battery cost models, because they are still I would say overlooked. The copper is more costly and more heavy, so there is more, I would say, focus on that. But even the copper is not getting the attraction that is needed, and we know that today those minerals are critical for the electrification, and it's getting and gaining more interest.
So maybe Moshiel, just to play back what I heard and to make sure that everybody understand, even those that do not have energy storage experience. So a battery, to put it in a simple description, there are people mostly talk about the active materials, and for example, when we talk about NMC batteries, we talk about nickel, manganese, and cobalt. So we're talking about different chemical compositions for the cathode and different chemical composition for the anode. People might have heard about graphite. Recently, we hear also about silicon. But anyway, there are different materials mixed together on the cathode and different materials mixed together on the anode. And then the way that these things are produced is there is a long sheet of, in that case, copper for the cathode, okay, a long sheet of copper for the anode, sorry, very simple traditionally, very thin layer, on top of which you put all the active materials, and then you need to dry it, to press it, and it's a long and complex process, but this is how you produce cathode and anode, right?
Correct.
Okay, good.
Yeah, thank you, Shai. And the goal of Addionics is to change that, to change the way that this structure are integrated in the electrode manufacturing process in order to reduce cost and to improve performance. The concept of 3D porous current collector is not new, so we're not the first one that the smart people that think about it. Many were thinking about it before, even technologies before lithium-ion batteries used, for instance, nickel metal hydride use nickel foam. But with lithium-ion batteries, which they are mobile, this is actually what make the mobile revolution. We are carrying our mobiles in our pockets and laptops, etc. You need to have million batteries a day at competitive cost. You need to make them as a commodity, cost-effective, and all the alternatives is I would say smart 3D metals or porous metal, etc. To manufacturing those metals were very expensive, so it wasn't applicable to the lithium-ion battery market. And the foil were good enough, so nothing was able to compete with the conventional foil. And this is what we put as a target to change. And we really understand that the world is moving to electrification very fast, from EVs to humanized robots, space application, data centers. Everything requires batteries and energy. The world needs more energy, and batteries probably is the best, I would say, a solution to store energy, to make energy mobile, and of course, also in terms of the environment application, it's friendly and it's better than to burn fossil fuels. So the world definitely require better batteries. For certain application, batteries are good enough. For certain, it's not. We can tap on few applications where there is nothing available which is good enough for them in the market today, and they need to have a customized solution, but they have low volume or they are niche, so the market is not giving them the attention that they need. And we are going there to really being able to customize, being able to serve the market with specific solutions, specific needs to overcome certain pains. And that's something that never done before. The relationship, as I mentioned before, between the current collector, everyone was like looking on the chemistry, and we are thinking about this problem from a different angle. So we are also wants to increase the energy density, but how we are going to do it from current collector? Current collector, it's a metal. It's not contributing to the energy. So we came with like a nanotechnology approach, is to move to 3D pore structure, and then we can reduce the amount of the metal. So we change the proportion. Instead of the metal in that real estate that we create, we put more active material. So it's a, I would say, different way to have the same result, and that's, as I mentioned, was overlooked. And the goal is to make this structure uniform with repeated pattern, with very, I would say, a uniform design, repeated design, to make it also repeatable in manufacturing. You need to manufacture that at scale, and to be able to integrate that smoothly into existing cell design. And that's something which wasn't, I would say, possible before with other technologies. And we remember the meeting with LG. They told us, if you're going to change the manufacturing process, forget about it. You need to make it drop in as a smooth integration. And this is where I would say our goal and what we're doing, exactly making sure that we are introducing a material that can be drop in to existing process.
So maybe just to make sure everybody understood, if what we see here, it's a zoom in image of Addionics current collector. And if we remember the previous slide, we had this like orange copper foil that for 100 years was a kind of very basic and dumb piece of metal. And your innovation was to make this foil a 3D and porous. And this is where the most of the IP of Addionics started from, right?
Yeah, definitely. And I will go in the next few slides and I'll explain actually further about the architecture, how we design it. So you can see in the image that you have like mountains and valleys and you have holes. So it's similar to a wave function, but I will speak about it later. Maybe to give you a brief overview about the company. So as I mentioned, we established like more than 7 years ago. We raised in total $80 million from a strategic investor and financial investor. I'm now in New York City, like sitting in the office of one of our investors that in this table. And we have a very unique position. So you can see that our customers and market is different, I would say, categories in the supply chain. So we are very attractive to different categories because we are attractive to metal manufacturers that produce foils today. And for them, it's either to not to lose their current business and to generate new business, to battery companies that wants to make their production more effective, to machinery manufacturers that wants to build and to go up in the supply chain. And that's something that we'll announce very soon about collaboration with few I would say, manufacturing companies, and of course the end user, if it's automotive OEM, so other, I would say, type of companies that we are working with that want to have a better product. We filed 35 patent application, and we recently opened our facility of 1.5 gigawatt hour manufacturing facility of porous metal foil. We have presence in the US, Israel, Europe, UK, and Korea, and soon we'll have another office in Asia. And that's something which is really helping us to engage with the customers, the ability for us to have teams around the globe close to the customer, helping them to also integrate the solution smoothly. So moving back to the product, as I mentioned, we have a porous 3D current collector, both copper and aluminum, copper for the anode, aluminum for the cathode. We are building and manufacturing the current collector in a roll format, so it's suitable for the formats that battery electrode companies using today. We manufacture that in a cost-effective manner, and also the integration make the battery manufacturing process more effective and efficient, and we can save up to 10% per kilowatt hour at the cell cost, and this is very significant, no matter what would be the cell format or the chemistry. Or, as I mentioned, it's more like architecture, and it's lots of benefits thanks to the manufacturing process. For instance, the drying time is faster, the filling time is faster of the electrolyte, and the porous structure allow better transportation, and the adhesion is also better, so we're increasing lifetime, and we'll talk about the performance improvement later. And as I mentioned, a requirement in the battery to have technologies, if you are, it's a solution that need to be integrated in the production. No one wants to change or replace their billions of dollars investments on their gigafactories. So the solution should be able to integrate into the existing factories. And this is what we build. We build a platform similar to the foil. So we took the advantages of the foil, that is a chemistry agnostic. You can use it in every format, any battery process, dry, wet. And we took that as something that we must have a parity in the characteristic of the metal in terms of strength, mechanical strength, conductivity, etc. And that was one of the challenges that we took at the beginning, to make sure that we have the same, at least parity characteristics of the conventional foil in terms of the properties and performance, but we have the additional advantages during the manufacturing and during the operation of the battery. So we can look on the architecture as a wave function, where we control the amplitude of the wave and also the frequency. And you can see that the holes or the porosity is very uniform and repeated. And that's something which is very critical to battery process and how the battery operate. You don't want to have any localized areas which are different from others, because this is caused to hotspot and localized degradation. And that's the way that we control. At the beginning of our work, we run many models and simulation, and we are using even AI to understand how the architecture affect performance. And we learn a lot from this ability. At the moment, we're trying to have a generic, I would say, solution as much as possible, but we are also working on next generation of production that will be able to customize the structure with a push of a button. So it will be very fast to make any adjustment, any customization. But right now we are trying to go to commercialization. So the effort is more to make, I would say, several, but limited a number of products that will serve the entire market. So in terms of performance, I mentioned, like, for instance, 60% longer lifetime in certain cases. In cylindrical cells, we found that we can improve the energy density only by changing the current collector with the same chemistry, by 12%, which is significant. We are drop-in solution. We already managed to integrate it into gigafactories, and I will show a few slides of the integration. And we managed to prove that this technology is a platform and can be integrated with different type of chemistries, state-of-the-art existing chemistries, and also a futuristic one. So this is the site that I mentioned that we opened recently, and can manufacture up to a 500 megawatt hour. This is for copper. It's with a width of 700 millimeter, produce porous material. And this is the world first, I would say, production based on existing manufacturing process. And that's what makes also Addionics very attractive. We are using existing CapEx, existing production standards of electrodeposition of copper. This is the way that the industry make copper foil for batteries. And we're taking the same CapEx, same process, and instead of having at the end of the process a battery foil, a commodity product, with the same low-cost CapEx, we're producing highly differentiated product, porous 3D, as I presented before, and you can see the material is transparent. You see the shoulders, the edges that are dense. This is important, and we can cut it for different sizes, but we want to make sure that the edges are dense, mainly for the mass production requirements and facilities when you need to have alignment, and that's a requirement for that.
Moshiel, how much less? I don't know if it's if what I'm asking it's a good question or a stupid question, but how much less copper do you have in a square meter of Addionics foil compared to a standard foil?
So it depends on the porosity, but I would say on average it's 30%. So per meter square is 20% less copper. It's the porosity, and this also make the production cost effective as well, because the production cost of copper is proportional to the feedstock of copper. The process of making copper foil, you take recycled or high pure recycled copper as a feedstock. You dissolve it in sulfuric acid, and you create a copper sulfate as a precursor. And this copper sulfate, when you are applying current, you can deposit it copper ions, free copper ions in solution on top of a big drum that rotate, and then you can peel off the structure. So we're taking the same process. We need to use less electricity for the deposition and less feedstock. If it's 30%, so it's linear proportional to the porosity level or the amount of copper that you save.
But I imagine the attractiveness of your copper is less about the cost, because the current collector is not an expensive component of the battery. It's more about the performance that you enable.
Yeah, performance is more, I would say, attractive. I think the combination with both, because you cannot, I would say, produce a solution that will be much more expensive than the current one, because there's no any appetite for that. And with the prices and recent prices of batteries, everyone wants to make batteries affordable and even with lower cost, and companies even losing money and selling components in raw material prices because they don't have any choice.
Yeah.
We do it also with the aluminum. Aluminum is a different process. If the copper is electrodeposition, so with the aluminum we are doing electroetching, so removing material. Aluminum is not as expensive as copper, so it's allow us to remove material. And when we combine the two as a bundle, we actually it's also attractive in terms of cost as only a product. But as I mentioned, overall we can reduce the cost with all the benefits. But you can look on that on performance improvement solution. So here you can see from production of the material to integration. This is in a gigafactory, double side coated, calendared in a roll-to-roll solution. And according to our knowledge, it's the first time that the industry managed to take this type of material and to do it in a gigafactory environment. And we managed to produce cells up to 100 amp power automotive power cells. We talked about the challenges at the beginning, but this is how we started. We realized from the industry what can be a big challenge, like how to make the coating in a roll-to-roll, because this is how the industry works. Bleed through, when you coat porous material, the slurry of the active material can leak from the porous. So how to make a structure that will prevent that leakage, how to make the calendaring stable without destroying the architecture of the 3D, and how to do also the tab welding without any change of the existing tab welding. So this is a roll-to-roll of cathode production process, and this is an old, I would say, video, but you can see there is no bleed-through. This is in purpose, although we got filmed it only after the first coating, only from one side, so we can see that the other side is like clean without any, I would say, signs of a bleed-through. We recently partnered with Avery Dennison. Avery Dennison is a global manufacturer, and they are helping us to scale up the technology. So the goal, and I would say the business model of Addionics, is not to be a manufacturing company, is to provide the technology to work with companies that they have the experience, the knowledge, the expertise, how to scale technologies, and partnering with them actually allow us to make sure that we can expand globally with a global footprint with a faster time to market. So the increase of life cycle is mainly related to the better addition. This is the elimination of the active material from the current collector. This is the main degradation mechanism, and we prevent that. And also the cell is more robust as we have better, I would say, or lower internal resistance and better flow of the electrolyte. So if there is a starvation of electrolyte in one area, spontaneously we have this flow of electrolyte to another area. And today in a dense foil, electrolyte cannot travel through the density, and we don't have the same, I would say, diffusion as we do have with the porous structure. This is in terms of energy density. So we mentioned about like unutilized real estate. So you can see in the pores, we can put more active material, and this is real estate that is not utilized. So this is for free, it's available, and we can grab that energy density only by making that porous. And that's, I would say, can sum up to a few percent for in total of the battery. And this is significant. Every percent of improvement is significant. For certain application, it's even a must. So main market is the EV market, but we're also very active beyond the EV, working with battery manufacturers, defense application when weight is important, and power. Discharge is more important than charge, and we have discharge improvement of between 30% with our porous current collector. Aerospace and space, satellites, but that's something which is quite interesting pain. Satellites, they have a storage battery with a solar panel, but there is no any application on Earth that's similar to satellites, because the satellites spin the Earth 10 times a day, and the lifetime of the satellite determined by the lifetime of the battery. And the battery cost of the satellite is only a fraction of 1% from the cost of the satellite. So it's a bit ironically that the other 99% determined by the 1% of the battery. So if you can improve lifetime and also make them lighter, this is something that the company is looking for, and nothing actually good enough is available in the market. And it's in the terms of volume, no big battery company willing to manufacture bespoke solution for them, because it's small. And the energy storage market is growing very fast with data center backup batteries to balance the grid. With all this revolution, we need more energy, for charging, for backup, for storage. And batteries, as I mentioned, is the best, I would say, solution to store energy. And we see a growing demand and need for a solution that can improve lifetime, but also can reduce degradation and get higher capacity retention. And this is exactly what we are doing. So the vision is to improve any battery in the world, any chemistry, any process, any format. And the life mission, our life mission, is to make sure that we replace the current collector, the conventional 2D metal foil, with our smart porous 3D current collector, and make a better future for everyone. Thank you.
Well, thank you very much, Moshiel. A couple of questions that came in, and we'll see if we have time for most of them. The first question, with regards to the way that you designed the grid, or the way that you designed the 3D current collector, did you use any multi-scale modeling, simulation, AI, computer tools to test different options?
Yeah, definitely. I think from day one, that's what I did during my PhD. I used multi-physics simulation to better understand how the architecture of the battery controlled performance. And that was also the concept, the idea when we started the company, is not to just, to manufacture and to test. Eventually, you need to do it. But if you want to minimize the number of variations and to run millions of models in simulation, so we gain, I would say, support. And I think we're one of the early companies that started to do it back then. I remember I did those models. It was like in the academia, it was very pioneering. And in the industry, in the battery industry, it was like a black box. And when I came from, the semiconductor industry, that was the tool that everyone used. Before you build a chip, you run like millions of models to make sure that it is optimized. And in the battery, it's like a black box. Don't touch it. This is how we managed to optimize it. We don't want to make changes. And that was I would say, a very important part, how to bring the semiconductor brain into the battery. So it's like making a battery lab on steroids without actually building batteries, or without having a lab, only by these simulations. And we started with, I would say, at the beginning with COMSOL and ANSYS and this type of multi-physics to show how we can build the entire, I would say, environment and system for current collector. So there are many aspects of the modeling on the structure itself, how the structure integrates during the manufacturing process, and also during the operation of the battery, all the electrochemistry performance.
Interesting. Another question, was there a moment or a day or a meeting in the last 7 years where you felt, okay, it's not going to work? And maybe take us back to that moment, and what happened and how did you overcome it?
So for me, it was very clear that eventually the world will move to better current collectors. So, it's very clear. The sun is shining, the wind is blowing. The next current collector will be porous. It's still something that I believe, that I wake up every day and I know that someone will do it. And so I never actually were thinking that it's not going to work or it's not going to be in the market. I think that the challenge is like, who actually going to do it, who will be the first to do it, and who will be the market leader. And that's exactly like our motivation and life mission, to make a successful story, to make sure that we will be able to commercialize porous current collector in worldwide use, and to do it faster, and to be the first to do it. And that's the motivation, and what actually make myself and the team motivated around it, because we know for sure that eventually the market is huge and the market needs better solution improvement. And as a former scientist and engineer, I can tell you, the way the battery is structured today, it's not optimized, and we can make them optimize we can have room of improvement. So now, why not to do it? So if something is not available, it's not mean that we need to just accept that, and we are not accepting that and making the change.
Yeah. Final question, maybe two questions combined together. Where will Addionics be in 2 years, and what are the 2-3 things that keeps you awake at night, other than your business?
Yeah. So the goal is to have those commercial agreements at scale, to have manufacturing also partnerships with companies that will produce it at scale with global footprint. So at least we want to do it with different sites, first in North America, but also in other continents. So that's like in 2 years, and to have those offtake agreements and contracts with the end user that's going to buy the material. And I believe that by the next few years, we have many activities that's coming along together, which allow us to create very strong and big, I would say, acts. And we'll have lots of strategic opportunities to do that in 2 years. And what actually makes me awake, or not actually why I'm not sleeping well. So first, I'm traveling a lot, so all the jet lag, etc., that stuff. So if it was any solution to make sure that I can do transportation, maybe teleporting, and to be in different places, because I remember during COVID, I was super happy that I don't need to travel so much. But eventually, you understand that there is nothing better than the physical meeting. We are a chemistry agnostic solution, but at the end, the world is working on chemistry between people. You do business with people. People wants to make sure that they are going to have fun with you. They are going to enjoy, and also you build trust during like those in-person meetings.
Yeah. Well, thank you very much. It was very insightful, and I think you guys are doing a great job, and I'm sure you'll be successful. And I hope maybe our guys could help you be even more successful, but that's for a separate discussion. So yeah, thank you very much for joining us. Have a good rest of the day, and we'll see you next time you are back in Tel Aviv.
Perfect. Thank you very much for having me. It was a great pleasure. Yes, looking forward to our collaborative work with the team at Orbia.
Take care.
Bye-bye.